All right, ready to go? Good morning. Thank you very much for coming. I mean, first session, it's always like heartwarming to see people that actually made it. It's not too early, but it's still, I need to start the Zoom. Okay, let's start the Zoom, because the organizers will be upset with me.
Recording in progress.
Okay, recording is progress. Just like a wrong audio and wrong video. We don't need video. We don't need video and screen sharing. I need to share this. All right, I think I did all the right things, and well, we'll see if I get screamed on. Apparently I won't. Okay, so this talk is a result of an argument that I had with Sasha, who's right here, and we'll try to recreate some of it on her podcast that is called Argonaut Podcast. Right, so I was invited to be on a podcast, and then we went into an argument for an hour about this topic. Did we solve DevOps or not? And I mean, you will see whose side you choose in the end of this talk, because Sasha is right here, and knowing Sasha, she will say what she thinks about all this crap. So it's going to be interesting. Let's see if it holds any water. So my name is Baruch Sadogursky. I'm at jbaruch everywhere on socials, Blue Sky, whatever the cool kids use today. Developer productivity advocate. Well, developer advocate talks about developer productivity, hence developer productivity advocate. This talk I do in my hat of developer relations advisor for a company called Gradle. You might know Gradle from their build tool for JVM tools, but Gradle is more than just an open source build tool. It's actually a company that tries to improve developer productivity from different angles. And the DevOps thinking about developer productivity is one of those angles. I hope I'm qualified to talk about that, because my background is a software developer first, and then I spent 11 years in a company that you might know called JFrog, and we pivoted with JFrog into DevOps, very tools for DevOps, very significantly, and all this background kind of highlighted the importance of developer productivity for me personally, and this is why I'm so passionate about that. I co-authored a couple of books that are very relevant to this specific topic, namely DevOps Tools for Java Developers, which is exactly the intersection of development and DevOps tools, and Liquid Software, about how we should release software. The most important slide of this talk is this one, show notes. If you go to speaking.jbaruch, before the CH, thank you Switzerland for the domain. Slides are already there. The video that I hopefully recording, tapping all the right buttons, will be there later today. And all the links for everything we're going to talk about are on speaking.jbaruch. Conveniently in the bottom of every slide, together with hashtag DPE. When you praise this talk on your socials, don't forget to hashtag DPE and hashtag DevOps Vision, obviously, and at jbaruch as my handle. All right, so exhibit A of the fact that we solved DevOps is the Accelerate State of DevOps report from DORA, which stands for DevOps Research and something. I don't remember. Anyway, DevOps Research and Assessment Institute. Here we go. Still have it. And they do a survey for a decade, asking different people in different companies how are their DevOps. There are, the report changed throughout the years, so it makes it a little bit hard to compare, but there are some constants that are with us for the entire decade, and that's the 4 main assessment categories that DORA does. And this will be deployment frequency, change lead time, change failure rate, and mean time to repair. Again, the names changed a little bit over the years, and also the definitions, but the basics that we can go and try to compare are still there. And you can see here, lead time is the time it takes for a code commit or change to successfully deployed to production. Deployment frequency, how often application changes are deployed to production, and change failure rate, the percentage of deployments that cause failures, which like we deploy bugs basically, and failed deployment recovery time after we deployed bug, how fast it will take us to recover. Right, so there is one of them that is particularly important for developer productivity. We'll get to it in a second. And this is how it started back in 2015. You can see here there was 3 back then. We had the deployment frequency, the deployment lead time, that's the lead time to production, and mean time to recover. It was back then, now it's to restore. And you can see the 4 clusters of super high. They changed the name to elite after high, medium, and low. And you can see here the distribution of deployment frequency. And obviously, as you would expect, deployment frequency for super high will be lower than the deployment frequency for the other groups. And it's the same throughout, right? And here is an example from 2018. You can see here that's kind of not the first time, but one of the first time they actually published how many companies fell into what bucket. And you can see here that we have 15 low performance, 37 medium, 48 high, and then elite. Elite was in some time interpreted as being a part of high performers. So it's actually 41 plus 7 here. In other times, it was a category by itself. And then you can see here, again, what the cohorts do. Deployment frequency, you would expect from elite to deploy multiple times a day, and they actually do that. And lead time for changes, you would expect, obviously, very, very high time for lead time, less than 1 hour. Okay, wait a second. Less than 1 hour for what? Commit to deploy. But is it the lead time? Is it really the time from when we said, okay, we need this feature in production, to the time when this feature is in production? Not really, right? It brings a lot of questions. And the first question is it really DevOps report or is it Ops report? You know what I mean? This is a very Ops number. From the time that the developer said they're done to the time that it is in production. It's the Ops part of the infinity loop. But it's not really DevOps because it kind of ignores the dev part of it. So that's an interesting thought. And it also goes into, all right, what about developer productivity? Maybe the developer, it took them 2 months of stupid meetings to actually do a feature that they could do otherwise do in 5 minutes. How it is reflected in lead time, because it is a lead time, or maybe not at all. Anyway, interesting food for thought. 2024, that's the last one that we have, and it's out, like, obviously right now. And you can see here the picture. Again, change lead time, less than 1 day. It was a couple of hours, just a couple of years ago. And then deployment frequency on demand, change failure rate 5%. This is extraordinary. 95% of code that the elite organizations deploy is on point and works as expected. This is wow. Failed deployment recovery rate, less than an hour. Oh my God, this is like, remember Equifax? They're like the entire thing that they leaked, they were leaking data of social security numbers and what's not. Their their recovery time was a couple of months. And we are talking about less than an hour. That's extraordinary. And well, percentage of respondents, also the cohort elite, it was 7%, and now it's 20%, which is very sweet. It should into high. The medium was 35, it's 37, and the low was 15, and now in 25, ouch. Right, so this is the cluster changes over time, the cohorts. I mean, I was surprised when I did this chart to not see a very clear movement from like going from low to elite. And what is especially concerning is this. I don't know, you shouldn't be surprised about the timing, right? 2021, COVID, working from home, silent quitting, drop in motivation, you name it. It's turbulent times. But this, I mean, numbers don't lie, this is what it is. The elite is getting larger. That's what kind of brings us a little bit of reprieve, but it is a little bit disconcerting. But for the purpose of our talk, I want to concentrate on something very specific in this graph. This graph basically tells me, okay, nothing really changes. People who want to excel, and they actually excel more. And then, like, okay, medium, those are obviously behind, and they kind of on the same level. Those people are like just not gonna get it. They don't wanna get it. Right, those do something, maybe they try to do DevOps or they pretend to do DevOps, and again, they're not really changing. And then those people, and it's more than a half or around a half, that actually kind of wanted to do DevOps, just do it for the longest time. This doesn't change, or almost doesn't change. And the fact that we don't see trends that, hey, people are trying to get on this and there are more and more people are doing it, but instead it's pretty steady and people just like, okay, we know what to do, whether we decide to do it or not to do it, that's up to completely different reasons. It's been 15 years, there are books, there are videos, there are certifications. People know how to do DevOps. They might not want to do DevOps. They might decide not to do it correctly. They might not want to learn. But whoever wants to do it, my, at least, idea is that they can do it. There is one thing that for me, as developer productivity advocate, is specifically important in the entire DevOps, or especially DORA report, and that's the lead time. And I already alluded to it when we spoke about it. The time it takes for a code commit or change to be successfully implemented in production. First, here, what we see is that, as I mentioned, it's a very ops metric from commit. It's kind of, if we look at our infinity diagram of DevOps, commit is not the beginning of the journey. It's the middle of a journey. There is the entire dev part before, all the plan, code, test, and all this kind of stuff, right? All this part, for some reason, not measured by what's supposed to be DevOps report, which is concerning by itself, but even here, even if we look at this metric as it is now, we can see a very interesting trend. This is lead time over, this is only lead time, and this is the changing over time since 15 to 24. This is a very strange graph. And trying to figure out what's going on is fascinating. Okay, good are stable, fair and poor had this drop, COVID drop I call it, and then they kind of recovered after it. But this is fascinating, right? The elite group, the best of the best, for some reason, started to do worse in lead time. Why? Why do we have this decline in one of the most important metrics in DevOps?
They finally tell you the truth about how they're doing.
They finally tell us the truth of how they are doing, which very well might be the case, but only the best of them decided to kind of start to talk about it. What about the rest of them? Well, they probably just started to be truthful a little bit earlier, and then they get back to lying. I have another theory. And another theory is that in some point of time in Dora report, they kind of realized that lead time is not from commit. And you can see it in the methodology. Dora report generally got better in being DevOps report than not just Ops report somewhere around this time. Somewhere around this time. 18 was very Ops report. I guess if you want to follow the history of...
Did they actually?
Yeah, they did. Yeah, they did. And not only that, I have another talk which talks about generally adoption of DevOps from the Ops part perspective. And it became much more DevOps. They started to actually ask developers, not only Ops people, for the DevOps report. They started to measure stuff which include the developers and not DevOps report. And this happened exactly right. Let's see if this works. Ah, here we go. And that happens somewhere here. If you want to follow like the history of what happened to the institute itself, it was actually acquired by Google and Google Cloud, and this is where the kind of a lot of things changed. Not all of them for the best, but definitely the inclusion of the entire like dev perspective in it made it into the report, and this is where this started to happen. The fact that they converge tells us that the difference wasn't that big to begin with. The difference was huge here when DevOps report measured Ops. When DevOps report measured time from commit to production. And the difference there was huge because it was a difference between manual deployment with basically logging in into servers and transferring files through SSH and modern SRE and platform engineering tooling like deploying to the cloud with Kubernetes and a continuous delivery. This is where we saw a huge difference. But when we factor in developer productivity in it, this is what smoothes the difference between, hey, we deploy very fast, but we develop 2 weeks prior, to, hey, we deploy very slow, but we develop 2 weeks prior. Suddenly, the deployment part is not that important in the grand scheme of things. And yes, the difference is still huge because best organizations are better in developer productivity as well. Not only in the deployment part, but in the end of the day, creating software takes longer time than deploying it, even if you are much more efficient and productive, and this is why we see the difference in that. So, the reason why all those parts matter is because DevOps is, in the end of the day, should be the entire process. We used to, when we tried to figure out DevOps back in 15 years ago and we didn't know how to explain it, we came up with a bunch of very stupid diagrams like this one. Remember this one? This diagram doesn't make any sense because it doesn't say anything. What does it mean that DevOps is in the center of Dev and Ops, that's hence the name, but also QA, doesn't mean that you as an individual should be proficient in all the aspects of software development. Probably not, because specialization still exists and you probably won't be able to learn everything about everything. So this is not very productive diagram. Then we start talking about, okay, this is something that has to do with people, process, and tools. All of them should be changed in order to achieve better delivery of software. Now it starts to make more sense. Okay, how do we change our process to be able to achieve those goals? Which tools should we use to be able to achieve our goals? How people should behave in order to achieve those goals? And us being technical people, we went all the way to tools and stayed there forever. Right? Most of the talk about DevOps will be talk about tools. All the DevOps certifications will be, this is how you use Kubernetes. And most of the DevOps conferences will eventually become on, hey, how do you deploy software on GitHub Actions? This conference is trying to bring content, not only how do you deploy your software on GitHub Actions, and this is why I'm staying here, and this is why you attended Sasha's talk yesterday about and today about not tools, but still most of the content will be about tools, not because we are evil and want to confuse people, but just because we're technical people and we feel the most excited about tools, which are essentially right. What we want to achieve in the end of the day is a combination of productive tools, productive process, and productive people working together to create and deploy software. This is the end goal of DevOps, kind of obviously. And we actually figured most of it out. So we know exactly what productive process is. Those are your vertical teams in which you have representatives from, or not representative, in which you have developers, ops people, QA people, product people, security people. Everybody work together to create software. This is what you should do. And when I say we figured DevOps out, I'm not saying everybody doing it. More so, almost nobody does it. How many of you have this vertical empowered teams that combine people from multiple teams in your organization? Yeah, well, kind of, sort of, 2 people out of everybody. Does it mean that the rest of you never heard about the idea, or don't think that it's good, or don't think that it's the right thing to do? No. It's just like, hey, there are reasons why it's not happening. So yeah, we figured out it's just not doing it, but we know what to do. We know how productive process for creating software looks like. The same with tools. We know how productive tools sort of kind of look like. We can argue whether it's very productive or not, but in the end of the day, we can envision today, in 15 years in, basic concepts of what productive tools are, right? We know that it's scalability matters, that cloud native should be involved, that our tools, that there is like a list of what site reliability engineers and platform engineers consider software that is DevOps ready, right? And we can ask them and they will tell us the checklist. So we kind of know the tools as well. The real question is the productive people. How do we make people productive? And you saw how discombobulated the entire thing got, all the DevOps support got in the COVID and post-COVID era. Because are people productive? How do we know if they're productive? How do we measure their productivity? And what do we do to make them more productive? And for me, this is the next frontier. The production systems of your production systems. Before your code is ready to go to production, the ops definition of lead time that is skyrocketing and going up and going from hours to minutes to seconds on how fast our machines deploy to production, and this is very merry, but has nothing to do with DevOps productivity. The dev part of DevOps productivity is the next frontier. And this is where the pain really lives, right? When you start asking people, hey, what hinders your productivity? What's the number one answer? What hinders your productivity? Number one, stupid meetings. Right? Everybody, just hands down. That's for sure. Fine. If we now remove all the meetings, what will be your next bottleneck of productivity? Stupid daily toil, right? Stuff that just has to happen because someone said it has to happen, or because this is how your environment set up. If it was now the 80s, you would say something like clear case. If you're old enough to remember, you will relate. That's my number one productivity hindering thing. Today, build and test. If you're a developer, after meetings, if you eliminate meetings, this will be the stuff that slows you down. Now, obviously, I am biased because Gradle, right? But I can assure you that this is indeed the case. We did our own research. You should go ahead and do your own research. Ask your colleagues. Say, okay, forget meetings. What's next? That will be an answer in a lot of the cases. Now, when people say, well, I don't have this problem at all. My build is crazy fast, and tests are not something that I think about. What they actually mean is that they don't do any of that. And we spoke yesterday about an example of someone who deploys to production and then asks, okay, how should we test it, right, in the panel last night. So then this is definitely not something that they worry about, but you understand how wrong is it, right? And what else? Inability to easily troubleshoot and determine the root cause of build, test, and CI failures, right? So let's say, regardless whether you run build locally, and you really should, or you don't run build locally and you just deploy to CI to see that it fails, it's still, when it fails and you have no idea why, that will be a significant pain for you, unless you just don't care. But if you do, you know Josh Long, right? That's like the legendary developer advocate of Spring Framework. It's a walking legend. I've been into his podcast and I was like, hey, Josh, I mean, how's your build? Are you worried about it? How long it is? And he's like, oh no, my build is very short. I mean, it's fine. It's not an issue. And I'm like, when I hear that, my next question is, hey, and after you deployed whatever you built to CI, can you forget about it? And he's like, hell no. I'm just sit, like, bite my nails and watch either the email or the Slack for notification of success and failure, or I watch the logs on my CI server, and I'm like, congratulations, that's your build. You just don't run it locally, you run it in the cloud, but if you sit and wait for it, that's your local build. And when you tell me that it's short, you're actually lying, because how long is your CI? And he's like, oh, that's like 20 minutes. And I'm like, this is your local build. This is how your build looks like. So whoever treats their CI as their local build, or just local build. And when it fails and they have no idea why, this is also a big pain, of course. And then observability of analytics, test performance, and regressions. This is less on the mind of regular engineers because this is more of a managerial pain, and it should be. Your team lead should be worried that the builds of the people in the team get slower if they know that it gets slower. If they don't know that it gets slower, but they think about it, this is where they are. This is the 60% of, hey, maybe, but I don't know. And if people tell me that something wrong, I don't know why. Developer productivity engineering is one of the ways to improve developer productivity. There are many. Better sleep is down the most important solution for developer productivity. If people sleep more, they're more productive. Having less stupid meetings is a great improvement of developer productivity engineering. Working in productive environment and not in noisy open space is a great improvement of developer productivity engineering, of developer productivity. Those aside, there is also engineering part. What we can do to engineer better developer productivity. Is it instead of good sleep? No. Is it instead of having less stupid meetings? No. In addition, engineering is important. So what can we engineer to be more productive? Foster faster feedback. Hands down, the most important pillar of developer productivity engineering. If during our development we have faster feedback, we are more productive, period. We're going to talk about that. Toil, all the stuff that we spoke about that you have to do just because someone said that you have to do, and not because you actually feel that it's something that helps you to do your job. Effective tooling. My favorite example here is, speaking about builds, what do you do when your build fails and you assume that it's someone else's fault? You'll probably go, nag them, and dump your build output on them. Does it improve anyone's productivity? If you can send them a link with the context to exactly what went wrong, with a clear indication of what their action lead to that failure, that probably will be more productive. Automation and eliminating bottlenecks, this is the basic of DevOps, right? This is what DevOps kind of lives on. Eliminating of bottlenecks goes all the way from DevOps through the Phoenix project to the goal, theory of constraints, Dr. Eliyahu Goldratt. The root of DevOps as deep as you can go. Are we doing it for the DevOpsy stuff? Of course we do, because we figured DevOps out. And you look at your pipelines, your continuous integration, your continuous delivery, your way to production, it's completely automated and we eliminated all the bottlenecks. If you look at your development practices, oh my God, it's full of manual, stupid tasks and bottlenecks. Does AI help? I watched someone working with Cursor, which is one of those new fancy AI IDEs, and their process was mind-blowing. So they're like, hey, write this like service for me. They ask Cursor, and then Cursor, boom, does the magic, and there is a new service. And then they're like, manually open the terminal and run build and test. And I'm like, okay, this is stupid. You had AI just finished writing your code. Why wouldn't it run and test it? Okay, so manually they run and the tests run and then there are test failures. And imagine IDE, right? There is the chat of AI chat on the side, and there is the terminal on the bottom. And what they do is one window. They copy the error from the terminal and paste it in the chat and ask their AI to go ahead, analyze the error, and fix the errors, which AI successfully does. But seriously, what the fuck? It's the same tool. Just take the bloody error and fix it when needed, when your build fails, and run the build again, and do it until the build fucking passes.
But the developer wants to be involved.
They don't. They really don't. The thing is, when I look at it and I'm like, dude.
There's a couple of tools that do what you said, right? And eliminate the developer.
Yes.
And it's unnerving. It's like not pretty.
Yeah, well, you know what? Yes, you need to oversee, right? The tool that actually does it, it's called Windsurf. And this is idea that you can actually do that properly. You can say to begin with, hey, write a service for me, run a build. First we start with definition of what we want to do. And we go hey, I want a service that does 1, 2, and 3. Write tests that validate this goal. And then it generates a bunch of tests for you. And this is where you are as a developer, look at it and say, okay, those tests, when they pass, will actually do what I want them to do. And then I'm fine. Now implement those tests. Run the build, run the test, and iterate until all the tests pass. And then you can do whatever. You can sit and watch on what it's doing, and it's going to explain to you step by step, and you can also validate that they do the right thing. Or you can go ahead and, do whatever you want to do. Check your email, attend stupid meetings. And then when you come back, you will see a diff of what it actually does. And this is where you look at it and say, well, no, this is bullshit. Or okay, you know what, that actually makes sense. So yeah, we have the tools to automate and eliminate bottlenecks. Just don't do it for your development for some unknown reason. Observability and proactive improvement. Again, observability is something that we figured out, we solved with DevOps. There is an entire multi-billion-dollar industry of observability, Datadog, and what's not. For your production environment, for your ops part of the equation. How about observability of your local builds? Well, it dumped a bunch of exceptions on you. What else do you want? Organizational mindset is a very interesting one. And this is, I think, one of the big differences why for 15 years DevOps was considered, hey, let's see what we do in production. And we're going to talk a little bit about that as well. And generally, outcomes over output is a good idea, speaking about the entire build failure log versus the one meaningful line of what actually went wrong. And I want to show you a couple of examples of how small changes that you can do today can affect greatly your developer productivity. We just spoke about IDEs, right? About smart IDEs, about better IDEs. This is the slide when I usually used to praise JetBrains and their IDEs because how smart they are. Unfortunately, or maybe fortunately, that's not the only game in town today because they fall behind, because others catch up, whatever. Whatever IDE makes you more productive. And how much AI do you want into it, it's up to you. In the end of the day, if you can write code faster and in better quality, this is what matters, and you choose the right tools to do that. Test containers is another one that is right there in developer productivity engineering. This is a framework that allows you to do almost integration level testing with almost unit testing ease and speed and efficiency. Instead of mocking external services, it actually spins a mini-me of those services in containers for your test environment. So you get almost the real thing and it does it very easily and fast. So you get almost unit test level user experience by checking almost the right thing. It's great. Sonar and their tools, Sonar Cube, Sonar, whatever, like all the bunch of their tools that will check the quality of your code, both in development and in CI, is also very, very effective way to make sure that you will be productive in the future, because the quality of your code is how productive your changes to the code will be in the future. Flaky test detection. Well, flaky tests are terrible, and it basically means that sometimes your test passed and sometimes it fails and you have no idea why. And it's probably also not your fault, and the only thing that you can do is kind of retry it until it passes. If you ask AI, again, you are in your IDE and test fails and you're like, hey, what's going on? And your AI is gonna be like, hey, I don't know, let's add a retry. This is a terrible idea. Right, so it's a patch, it's a band-aid. Like, hey, if we run it again and it will pass, it's okay, I can ignore it and pretend it didn't fail the first time. But it really kills developer productivity because it's absolutely random. At least you just waste your time. At most you will end up with unexpected and you have no idea why it fails. Detection of those tests and actually fixing the root cause is really the way to go. And let's talk about faster feedback. Now, what is faster feedback? There are different expectations that we have from the speed of feedback that we have. Right, so sub-second efficiency is your IDE. If you write your code in your IDE and you typed spring instead of swing, it will mark it or instead of string, it will mark it red and you know that you made an error. Build, you want your local build to be seconds, basically, because you run something and then you want the results. CI will take minutes to up whatever it will take, and then production will take hours or days or again, whatever it will take. All of them provide you feedback. Production as well, right? That's your ultimate feedback. That's what your users use and tell you if they like it or not, if it works or not. But all of them provide you feedback. And as you can see, the further this feedback is from developers, the slower your expectations are, which is fine, because this is how you experience your development. And it generally works that way with the exception of build. Yes, IDE provides you sub-second efficiency, and yes, the CI will take whatever it will take, and the protection will take whatever it will take. Build, you expect it to be fast, and it's not. I mean, if there is XKDC comics about it, it means it's true, obviously. And this is one of the most annoying ones, for me at least, because yes, it looks like slow build is fun, but it's not. It's fun for the first time maybe, but it's more like this. It's very annoying when the build is slow. And one of the reasons that it's annoying is because you really don't know how to fix it. Bruce Eckel, the author of a lot of wonderful books, including Thinking in Java and many others, was so upset with his inability to improve the build that while his build was running, he wrote a very annoyed blog post that is called The Problem with Gradle. And he goes about bashing Gradle for a lot of time while his build is running, I guess. But in the end of the day, this is the most important line. To do anything, you have to know everything. Now, he claims that other build tools are not like that, and if you use, like, for example, Maven, when you have everything set up, and you can get started very quickly, and there is a merit to this claim. The problem with it that in Maven as well, and in every build tool, as long as you want to do something more complicated than Hello World, you will end up doing stuff that other developers won't understand. Not because you're evil like that, but just because build is a complicated domain. And being a complicated domain, talking about specialization and our mental capacity, on top of learning what you really should know, and everything that ops people want you to know, Kubernetes and stuff, you also need to know build. Well, build is complicated because there is a lot of stuff that is going under the hood, right? There is a lot of stuff that is going under the hood. And it's a lot. And everything of those can go wrong. And it obviously can go wrong in any time. Right? And build frustrates the developers because it looks like they can master it because it's a technical thing. It's just another stupid dependency that you have in your life that you can definitely learn, but you don't want to learn it because it's not something that you do every day, but it's slow and it affects your developer productivity, and it's just really, really annoying. Then we ask LLMs, and then I ask ChatGPT, hey, what techniques can I use to speed up Maven build? Number one is skip tests. This is a terrible idea. The whole idea you run local build is to get feedback. Hopefully you don't deploy from your local machine. So hopefully you don't really need those artifacts that are generated. The only reason you generate it is to get more feedback. And you know what? If you just want your build to be fast and you don't care about building, you can skip compilation and just compile on the production server, because what can possibly go wrong? We live only once, right? In the end of the day, we want faster feedback and not less feedback, right? What feedback do we want? Well, obviously compilation, if it's compiles or not, it's going to be nice feedback. Also, if the test pass or not, will be a nice feedback as well. But there is more. The ultimate laundry list of feedback can come from the place when we actually collect as much feedback as possible, and that will be your pipelines. And here you can find stuff like, well, it builds, it compiles, the unit test pass, the integration test pass, and then we can run for code coverage, and then linting, and then static code analysis for checking a bunch of stuff. This is like sonar part of the build. And then we go into security, dependency scanning, and secret scanning, and your static code analysis for security, finding your SQL injection potential sites and all this kind of stuff. And then you go into the weeds of like non-functional requirements like load testing and resource utilization and compliance and all this kind of stuff. So this is like the perfect feedback. And the perfect feedback that is collected during your pipelines, which is definitely not terrible. It's good that we collect it before we go to production, but it's also not great because, as you remember, CI can take very long time, and if you need to wait for CI to get your feedback, you will end up like Josh, watching your CI logs instead of doing something productive. And that's because we have two types of feedback. We have the asynchronous feedback and the synchronous, and CI is the asynchronous type. And that's the one that you shouldn't wait for. Once you committed your code, you should go ahead and start writing mode code probably, or drink coffee, or go to sleep, or go to stupid meetings, but not waiting for CI. You shouldn't wait for it. Yes, if it fails, it's going to be distracting. And this is exactly why people might decide to wait for it. Because they are not sure. Will it pass? Will it fail? It makes me anxious, so I'll just wait before I switch my context, and I'll just wait for it. But this is not how it's supposed to do. You should commit with confidence, and then you shouldn't wait for CI. What helps commit with confidence? Local feedback, synchronous feedback. Build. You build your software, and then you trust your software to pass CI. Does it guarantee to pass CI? No. But you have a certain degree of confidence that it will. And for a build, you wait. And if it's slow, it's terrible, because this is where you cannot do anything else. And the difference should be commit time. So you should wait for your build, and then it should give you enough confidence so you won't wait for your CI. This is how it should be. And what it means that you want all this feedback in your build. If you have all this feedback in your build, then you don't need to wait for CI, because you know it will pass, because the build just passed and it collected the same feedback. Is it possible? Not really. Because then what's the difference? If we collect the same feedback on CI and on build, then the time of CI in your build will be the same. But the whole idea is to make your build fast, while your CI is slower. So how do we achieve that? How do we do fast and maximum feedback? So first of all, there is no magic, right? Obviously, your CI will do more. It's slower, it gets more comprehensive feedback. But we can do a lot on local build that will give you the enough confidence to commit to CI and not wait for it. Will you occasionally be surprised that your local build passed and your CI failed? Yes. But the idea is to minimize those times so you won't be anxious about, hey, my CI will probably fail, so I cannot do anything else until I see it passes. That's the idea. There are two main techniques to achieve that. Avoidance of skipping what can be skipped in your local build, and acceleration, speeding up what you can speed up. So, skipping what you can be skipped. First of all, it's already done by your build tool. Most of the modern build tools do what it's called incremental build out of the box. And they try to skip what didn't change, what wasn't affected, and then not test either of those. How does it do that? Through observing your build structure, right? There are modules in your build. In your build, we'll say, okay, this module is independent on the other one. If the other one didn't change and this one didn't change, we don't need to rebuild it. But if this one changed, we need to rebuild it, but also we need to rebuild or retest this one because there is a dependency between them. Now, and how does it know if something was built or not? By watching the artifacts that we created and watching if the sources didn't change and we have the whatever artifacts for those sources and they didn't, and it matches, then we can skip it. Now, it's not ideal because it relies on produced artifacts, and if you deleted the produced artifacts, it will have to rebuild everything, and it relies on architectural decisions of those modules being properly designed and built, which is obviously not always the case. So what can we do better? Caching. Caching makes the build faster because it caches every task during the build, or any task during the build. It does it by, we define what the incomes of inputs of the task is, what the outputs of the tasks are, and then it will create a hash sums of the inputs and the outputs, and if the hashes didn't change, we don't need to run it. Now, another amazing feature of caching that it can be distributed. I can publish the hashes on a server that is shared by my team or my company, and then everybody on this team, instead of building a task, will check the hashes first and then decide whether they even need to run the task or not. And it works always, because even if I delete the artifact that I created, the hashes are still there, so I can still skip the steps of artifact creation, compilation, and everything else. And it makes all parts of the build faster, not only those that actually produce files and artifacts that I can compare, because hashes are generated always. Here is an example, and this is a screenshot from the Grail commercial product called the Velocity. Doesn't matter. It's just here to illustrate the savings that you get from caches. So here's a build time of, it ran 12 minutes, but it actually skipped 40. This is a lot. This is a lot. And if we look at what brought those savings, you can see that what it's called up to date, and this is your out-of-the-box incremental build savings of the build tool. This is 20 minutes, and this is the half of savings. The other half of savings are the caches. 5 seconds from local build time and 20 minutes. Half of the savings come from remote build cache. What happened here is that the entire tests were skipped because someone else on the team already ran those tests. They made a change of their code and tested it. I just checked out this code, didn't build it on local machine, didn't test it on local machine, but I don't need to, because I know that they tested it, because I got the hashes of the test results for those sources from them, like I run the tests. Another very powerful avoidance technique is predictive test selection. Now, predictive test selection is a machine learning algorithm that learns the code changes that actually happens and correlates them with the predicted results of test failures. And then it skips the tests with high degree of confidence, knowing that probably those changes won't affect the tests, so they can be skipped. Code changes and test results are thrown into a learning model for a very long time. You teach the model on your code base by saying, okay, I run all the tests always, and you observe. When I change something, take note of what tests fail and what tests pass, and learn from it. After a while, you will know how to guess how code changes affect tests. The model predicts which changes fail, which changes. And here's so we know what changed, and we know where it changed. And then we can correlate of which tests fail and which tests pass. And then we can predict which changes will affect which tests. It's fascinating how machine learning comes to a very human conclusions after a while. The more tests the project has, the less they break. It makes perfect sense to us. The machine doesn't know about this correlation, this causation. It can only do correlation. But when it does the correlation, the causation actually makes sense. There is one more that I particularly love. Refactoring in Java break tests less than in JavaScript. It makes perfect sense to us because this is statically typed and this is dynamically typed. Obviously, the IDE does the heavy lifting for us in the statically typed environment and has no idea in dynamically typed environment. But the test prediction model has no idea what I just said. It doesn't know about static, it doesn't know about dynamic, it doesn't know about ID and refactorings, none of that. All it knows is that if we have sources with .java extension, and we have another sources with .js extension, for some inexplicable reason, if we change variables in one, a lot of tests fail, and if we do, or don't fail, and if we do change the variables in another, a lot of tests fail. It has no idea why. All it learned is that, hey, we can skip tests in the former, and we definitely cannot skip tests in the latter. And that's exactly what we want. The public instance of the Velocity for Spring framework does a great job for us educating about predictive text selection because they never turned it on. They run it in learning mode forever, for years. And it's terrible for them, but don't tell them because it's great for us, because we can observe how accurate the model is. If the model is deployed in production, we have no idea. It skips some tests, it runs some tests, we don't know how efficient it is. But if we can compare the predictions with the actual results because someone forgot to turn it on in production, this is awesome. And that's exactly what the Spring framework does. And if you go to GE for Gradle Enterprise, the old name of the tool, .spring.io, ge.spring.io, we have it, I have it obviously in the show notes right here. You can see this. You go to predictive text selection and you see this. 98.7% of tasks, failures, predicted correctly. This is insane. Out of 2,700 correct guesses, there are 37 incorrect. And what do I mean by incorrect? It basically means the test that the model thought will pass actually failed. Now, the savings potential that they're missing out is also very, very significant. Again, don't tell them that. But this is extraordinary. The savings that predictive text selection can do for you is through the roof. Now you say, okay, but what about those 37? What about this, like 1.3%? Shouldn't we worry about these tests? They will be caught in CI. We don't use predictive text selection in CI, because in CI, remember, we don't care about how long it runs. We don't need to rely on avoidance techniques anymore. We're fine that it will run all the tests. And it will catch this 1.3%, and it will fail the build. Will it be annoying for us? Of course it will, because we thought that our local builds run all the relative tests, but it misses some. But it will be so rare. And the gains from going into CI with confidence that we don't need to wait for it are so great that this is a definitely acceptable amount of failures. Make sense? Okay, now, in the end of the day, we cannot avoid doing any work because we made some changes to our code and we want to correct this feedback in the end of the day. So how can we speed up what cannot be skipped? The most important improvement to your local build time is test parallelization. And that means that you really should use the max power of your local machine. Now, I'm going to make a case that you can I record the video, you take the next like 30 seconds of this talk, and you show them to your boss, and they buy you the whatever Max 4, like Pro, Max, Ultra, Mac, or whatever alternative that you prefer that are on the market. Watch me. I have a test, local build, running on this machine. It's nothing special, it just do like it's an example, so it has some service like pet shop, pet store, whatever, and it runs a lot of tests for this small application. And the tests are 2 minutes, which, as you can see, like the entire build. Everything else is sub-seconds. The longest part of the build will be test. 2 minutes. Now I change one line of code, and it goes to 10 seconds. 12-time improvement. I didn't touch anything in the code of the application itself. I didn't run it on any other hardware. It's exactly the same machine. All I did is this. 12 times improvement. From the insufferable for me with my ADHD, 2 minutes of staring and nothingness or the logs, to 10 seconds that I can say, well, okay, I'll wait for this build. All right? Congratulations, you just got your hardware updated. Now, you know what has more power than your local machine? The cloud. The cloud has unlimited power of unlimited machines. And we already use it for CI, for example. So CI use a technique that it's called fan out. During your CI build, your cloud CI will spin Docker images, Docker containers that will run the tests. It is done on CI not for the purpose of speeding out, but for the purpose of testing on multiple platforms, for example. It will spin out different containers with different architectures for you to test your software on different platforms, which is nice. But we can use the same technique for your local builds. Your local build, before the commit, your local build will send the tests to the cloud, parallelize it as much as possible, run all the tests at the same time, report back the results to your local build, and continue on your local machine to give you the local output. You can use the cloud to distribute test load, and it obviously comes with an overhead. Sending the test to the cloud, spinning up the Docker images over there, and then tearing them down, sending you back. So it's not always beneficial. But when it does, when you really have a lot of tests to run and your local machine won't do the job, this is an excellent acceleration technique. Because then you can run all the needed tests without compromising. You don't need to skip anything. You will still do the test as maximum test avoidance, right? You will still run as less tests than possible, but if there are still a lot, this is how you run them faster. Now, as I said, you already have this technique in CI, but it's not great. It's not great because you rely on shared CI infrastructure, which is not optimized for real-time feedback. Because remember, almost no one cares how long your CI runs. So, are the agent as powerful as possible? Probably not. Is the back and forth between sending the test and reporting back the results as optimized as possible? Probably not. Because they are not optimized for real-time feedback. And so those are the skip what you can skip and then accelerate what you cannot skip. And then there is the entire thing of don't let it slide. Make sure that you are watching degradations, right? And it starts with the little things. How many of you actually know how long your build is? You probably should, right? You run it every day, you kind of know. How many of you know how long the average of your team build time is? What about this developer that moved to Wyoming, speaking about Wyoming, and now works from a nice hut on the lake using Starlink to download dependencies? What it does to their build speed? You know, maybe it's faster, who knows? But maybe it's slower. But do they know if they're faster or slower? Do you know if it's faster and slower? And what happens to it over time? Find the root causes and improve. Again, doesn't matter the illustration. but the idea is here we have boiling the frog situation. The build time of the entire team creeps and increases over time, but not enough for you to make note every day. It's like your phone, right? In a couple of years, you have a feeling that it's much slower than it was when you bought it, but you don't really know. You just like have a feeling that everything is slow somehow. That's exactly that. Right, and then if you do those things, small things, the gains are real. So again, 84% of the organizations that embarked on developer productivity engineering journey report dramatical improvement in productivity. And this is not surprised. I mean, it only makes sense. Same 84%, I guess, report developer joy. Now, this is the show notes was the most important slide. This is my favorite slide because it has joy on it. And it brings me joy because, you know what? This is a nice feedback to have. When people say that development is joy again, as it used to be, remember when we got started? Our first, like, whatever visual basic hello word, wasn't it joy? Yeah. So, developer productivity, for me at least, is the next frontier, right? Again, we disagree here with Sasha, but I believe that whoever wants to do DevOps correctly knows how to do it. And if they don't do it, there are probably good reasons, but it's not 2015 anymore that we need to get and educate people what DevOps really means with those stupid Venn diagrams. And the next frontier, yeah, so if you want to excel in your production environment, not only you know how, you have tools and techniques to do that. And your path to production is our next frontier, and this is where there is work to be done. Developer productivity engineering is one of the aspects of the developer productivity, and this is where you should really do it. Now, the QR code goes into speaking.jbaruch, so nothing new is there. And there are a couple of ways for you to get started very easily. So Gradle does what it's called Gradle and Maven Build Speed Challenge. You just give them your build or take one of the open source that they suggest, and they're like, okay, change a couple of lines in your build and see the magic, and it's pretty magical. And if the entire developer productivity thing and developer productivity engineering in particular is something that kind of is dear to your heart, you have a wonderful opportunity now to be what we did for DevOps 10 years ago. Be this agent of change that will bring joy into a lot of developers' lives. Also, in speaking.jbaruch, you'll find a link to a free ebook about developer productivity engineering. And back in September, we had the Developer Productivity Engineering Summit in San Francisco. I'm not sure, maybe all the videos are already published, but the keynotes are published for sure, so you can watch those again. Everything is right here. With that, thank you very much. And JBaruch everywhere. This is DevOps Vision, and we spoke about DPE, and you go to speaking.jbaruch to find everything. We have 15 minutes for questions, or we can be first in the coffee line, whatever works. Yes?
So I think this is funny because I actually agree with you on most of the things that you said, and it turns out that the biggest argument stems from defining things differently.
As it obviously is, always, yes.
It turns out we actually do need to educate people about DevOps, because the biggest thing I disagree with you is where you define developer productivity versus DevOps, right? Because those are all the same things.
Yeah, they are the same things, but do traditional DevOps care about stuff that we just spoke about? Do they care about your build time, your test time, your local builds? Do they care about your IDE and how efficient it is? Or do they still consider the lead time starting from when you actually stopped coding?
So, I mean, you're more likely to see developers like DevOps care about CI than the build, and so like you're making trade-offs here between build and CI and whatever. But I don't know what traditional DevOps is because we've changed the definition every year for 15 years.
That's for sure.
And there's plenty of people who think that CI/CD is a very core part of DevOps, and there's plenty of people who are squarely on the infrastructure side and don't even care about CI. So,
Yeah, no, but even pre-commit, that's kind of the part where developer productivity engineering shines, the pre-commit part. And this is something that I feel is being traditionally neglected by DevOps definitions. But I mean, I'm glad that it's changing. And we started with how we see that suddenly the definitions change and then the lead time skyrockets because, hey, it's not only post-commit anymore. But I think, again, you're right. It's in the end of the day, it's all about that. And you know what? We can go back to say, you know what? It's all agile. Or we can go even further and say, you know what? It's all theory of constraints. It's all the goal. In the end of the day,
definitely is all theory of constraints.
it's all the same roots. But what we put our spotlight on and what we talk about matters.
So I know that you have a use case that you care about CI or length of CI, and probably the length of build as well. So I think that's an interesting conversation over here.
Lead time in general.
Yeah.
We've got a team that's building UI tests that are taking 12 hours.
Yep.
Unsustainable.
Of course.
So,
of course.
We're dealing with a heads and hearts change more than a technology change right now.
It's
technologically, I can do exactly what you're doing. I can show you the times, I can show you the patterns, I can show you everything, but I haven't convinced the heart and the head yet. So we're still fighting that.
yeah, and this is why we're here, right? This is what the idea of this talk is, to say, hey, if your build takes 12 hours, you cannot be productive, period. And you might not think about it, but you really should. Yes?
I think a lot of the developer try to do is they try to duplicate a lot of the quality checks that's happening in CI into the build process.
Yeah.
And that's causing a lot of the
Yeah.
that's eating up.
Right. Yes and no. So yes, just taking your CI and kind of saying, okay, that's what my local build will be, is not a great idea because, as we just spoke, we don't care about how long CI is, but we do care about how long build is. But also,
We do care about how long CI is.
kind of, sort of, less. Long builds are much more painful
Let's say
for.
if a CI is 20 minutes, it's okay. If the local build is 20 minutes, it's
Exactly, right. So we're more sensitive to what short is in build comparing to CI. But yes, so probably just taking CI and calling it a local build is not a great idea. But also, and this is the entire premise of the second half of the talk, is we want to compromise as less as possible when we take the checks from CI and bring it to local build. And this is why all the avoidance and optimization and speed ups, because we want as many checks as possible from CI to borrow into local build, but also optimize the speed. This is the entire magic of what Gradle tries to do, but you don't need Gradle for that. As long as you know that this is the goal, you can implement a lot of that by yourself or by using tools, by using Gradle tools, by using other tools, whatever. This whole talk is not about tools. It's about mindset.
I have a question with an ulterior motive.
Of course you do.
You were talking about productivity killers and the meetings being the biggest of them. Do you have proof in some Gradle research or anything?
Yeah, so the thing with the meetings is that I even bring it up because if I would start like, hey, your build time is the bigger productivity killer, you're like, okay, sure, definitely not, because meetings. But from developer productivity engineering point of view, meetings is not something that we really can do anything about it because you cannot engineer yourself out of meetings. Well, for now. Maybe with AI you will be, but not yet.
So I do think that Microsoft at one point ran a study and they decided that average developer codes for 53 minutes a day.
Yeah. So this is.
I just realized that I needed that in my slides.
Yeah, no, for sure. There is a lot of studies about developer productivity in general, and frankly, this is all the rage right now. Developer productivity is, and AI. After AI, that's the most hot topic out there today.
So really, for today,
Yeah.
we've been talking about meetings and time constraints, and when you drop back to theory of constraints,
Yeah.
time is
Yeah.
the ultimate one.
Yeah,
right?
for sure.
So we've been talking about this for 45 years.
Yes, but today, if you look at the hottest trends or in today's development, and I'm not talking about tools, I'm talking about processes, you will find that AI is like all the rage today. But the second biggest topic today is developer productivity in general. All the dx.org, devx.org, and Backstage and platform engineering in the developer productivity head of it, and not the DevOps tooling part of it. This is like what's all the rage today, and it's all about developer productivity.
And which is why I always say that ops is the forgotten pillar, not the dev. So everybody is like, we need to cater to developers and make developers happier, and we need to feed them better, and we need to give them more snacks, and then they will produce more lines of code.
This is
more
yeah.
money, right?
This is true today, but it wasn't. So it wasn't like it was like that always, but it wasn't the aspect of, how should I put it? The concept of developer productivity is relatively fresh, right? If you look at, so for example, Dr. Nicole Forsgren, one of the original authors of DORA framework and the DORA report and all that, what she does right now is developer productivity. A couple of years ago, a new framework that is called SPACE, satisfaction something, of measuring developer productivity she came up with, and now there is a new one that I keep forget the name.
DevX and DORA and SPACE, and I think
So there is one more that is newer than SPACE, that is also like a framework of measuring developer productivity. So even she pivoted, I would say, or evolved, maybe, from DevOps to developer productivity. And it's all the rage now. And dealing with context switching, concentration, meetings, how efficient we are in the end of the day of writing code, how many minutes, it's definitely in the minutes range, we actually do something productive during the day because of meetings, but not also. This is like, there is tons of research and tools that are going on right now about that. Developer productivity engineering is the really engineering aspect of it, right? Of all the research that is done right now, the engineering is one of them, and meetings is not there. It is big picture of developer productivity, not necessarily the engineering part.
I can see her disagreeing with that sense.
I mean, there is nothing engineering in getting rid of stupid meetings. Productivity, sure. Engineering, not so much.
I mean, a perfect engineering answer is that it depends, right?
Well, yes.
Because not every meeting should be an email and coordination and speaking to each other.
No, for sure. There is nothing as productive as meetings, and there is nothing as unproductive as meetings. That's for sure. I mean, absolutely. Yeah.
Oh, yeah.
Yeah.
You mentioned a lot about test containers. Do you have any more resources on how to either learn them better? Or
Oh yeah, absolutely. Just go to speaking.jbarov. There is like a link to test containers website, and there are talks about it. If you want to, you can check here as well. Back, I think, almost a year ago, probably, or in the summer, we did a round of a tour of Canada Java user groups together with the test containers guys, with namely Eli from one of the founders of Atomic Jar, which is the company that made, how should I say, tooling around test containers.
from the third one to that? Okay.
Yeah, it's right here. So just search for test containers on the page, and it will show you a couple of talks that Ellie did about particular test containers.
Okay.
So right there as well. Yep. It's amazing. Really,
I'll go through that.
definitely worth checking out.
I have a more general question about personnel. Like,
Yep.
how do you differentiate between like what people are, I guess, uneducatable, and what people are like? I kind of find in a lot of teams, they're like 20 to 30% of people are doing most of the stuff.
Yep.
And sometimes you think, oh, can we help people along to get them here or get rid of them? And also, I think that affects meetings because meetings, I think, could be really good if it was just talking to people like this.
Like productive
it's
people.
It's like you get
Yep.
people who just want to hear themselves talk and don't have anything to contribute. Is why people hate meetings.
Yeah. So again, unfortunately, this is outside of the scope of developer productivity engineering, but it's very in scope of developer productivity, and it's an interesting question of how people that shouldn't be where they are affect productivity not only of themselves but of others as well. And we're going way out of scope of this presentation into very managerial stuff. Are you around for the Tech Leadership Summit that happens after this conference? This is where those things are discussed. And it's, I mean, I guess it's too late to change your plan this year. But obviously there are videos that are published. This is why we record the Zoom stuff. This is like this type of discussion, right? What I can say in general, that we want to assume that people have good intentions and want to be as productive as possible. The reality slaps us in the face sometimes with like silent quitting and people that are not there to actually do the job. And this is what makes it interesting and hard. And this is why some people, like me, don't really want to get into people management, because people are not as nice as machines, which have predictable, short, reliable feedback and no alternative models.
Not with Gen, yeah.
Not with Gen AI. Well, yes. All right. Thank you very much. All right. How do I stop this thing? Where is my? It's right here. Here we go.
Well, I don't think that thing is recorded, but was it?